What if the food on your plate was tested for safety, not in a distant lab, but right where it was grown? Imagine a farm where invisible threats are stopped in their tracks, before they ever have a chance to reach your kitchen. This isn't science fiction. It's the new reality of agriculture. Welcome to the Fields of Innovation YouTube channel. Smart farming starts here. Discover the future of agriculture, where we share information about technology applied in agriculture. Today, we're digging into the revolutionary world of on-farm food safety testing. When you think about food safety, you probably picture inspectors in processing plants or signs in supermarket delis. But what if I told you that by then, it's often too late? The real battle for safe food begins long before it's packaged or shipped. It starts in the soil, in the water, and on the farm itself. Early detection is everything. Discovering pathogens like E. coli or chemicals at the earliest stage is the most effective way to prevent widespread outbreaks/food waste and ultimately protect you, the consumer. The modern approach to food safety is proactive, not reactive. Prevention will always be better than a recall. We've all seen the headlines. Widespread E. coli outbreaks in romaine lettuce, Salmonella scares in eggs, or Listeria contamination in dairy products. These incidents often start silently at the farm level, perhaps from a contaminated irrigation source or a sick animal. The problem is, they are usually only detected after the products have been shipped, distributed, and sometimes even consumed, leading to massive, costly recalls and a loss of public trust. These real-world examples highlight the urgent need to shift our focus to the very beginning of the supply chain. This is why farms are the first and most important line of defense. If we can make our farms safer, the entire food system becomes more resilient. The theme of today's discussion is simple but powerful. Genuine food safety starts in the soil. For decades, the standard procedure for food safety has been lab testing. This involves collecting samples, transporting them to a centralized laboratory, and then waiting anywhere from 24 to 72 hours for the results. This process is not only slow and costly, but it also requires expensive equipment and highly skilled technicians. The critical flaw in this system is the delay. During that waiting period, potentially contaminated goods can be processed, packaged, and sent out into the supply chain, creating a massive risk. Now, compare that to on-site testing. New technologies are empowering farmers to get results in minutes or hours, directly at the source. This ability to make instant decisions is a game changer. A farmer can immediately halt a harvest, isolate a sick animal, switch to a different irrigation source, or sanitize equipment before a problem escalates. This rapid response capability drastically reduces the spread of contamination and minimizes economic losses. The impact is enormous. Instant detection prevents entire shipments from being condemned and recalled, which saves millions of dollars and tons of wasted food. It's a simple equation. Rapid on-farm testing equals higher efficiency, greater sustainability, and most importantly, a higher standard of safety for everyone. So, what does this on-farm testing revolution look like? It's driven by a wave of incredible technologies. One of the most powerful is portable PCR and DNA amplification. These miniaturized devices, small enough to fit in a farmer's hand, replicate DNA from a sample to identify specific pathogens with lab-grade accuracy. Then there are biosensors, which are designed to detect pathogens and toxins in These smart devices often use strips or surfaces that change color, voltage, or fluorescence when a specific contaminant like Salmonella or a mycotoxin is present, giving a clear, immediate signal. Spectroscopy is another non-invasive powerhouse. Devices using near-infrared, infrared, or fluorescent spectroscopy analyze how light interacts with food. Without needing any chemicals or complex preparation, they can detect spoilage, chemical residues, water quality issues, or even crop stress, providing a wealth of information in seconds. Further down at the micro-level, AI-based sensors are being deployed directly in soil and water. These smart sensors continuously monitor crucial parameters like moisture, pH, chemical runoff, and microbial presence. An AI platform then analyzes this data, identifying patterns and predicting contamination risks before they even happen. We're also seeing the rise of biomimicry with electronic nose and tongue devices. These tools are designed to mimic human senses to smell for spoilage gases or taste for toxins and chemical residues. They are invaluable for checking the quality of livestock feed, stored grains, produce, and dairy products. All of these devices are often connected through IoT monitoring systems. Sensors strategically placed in barns, greenhouses, water tanks, and storage units send a constant stream of real-time data and safety alerts directly to a farmer's phone or dashboard, creating a fully connected and responsive farm. Let's get specific about what these tools are looking for. The primary targets are dangerous pathogens like E. coli, Salmonella, Listeria, and Campylobacter. These are some of the most common and hazardous pathogens that originate on farms and can cause severe illness. Contamination can come from many sources. Animal waste can seep into irrigation water, contaminating crops. A water source itself might be unclean. Feed can be contaminated with bacteria or mold. Even the movement of livestock can spread pathogens through the soil, and poorly cleaned harvesting tools can transfer them from one plant to another. The process of using a rapid test is designed for simplicity. A farmer collects a sample. It could be a bit of soil, a water sample, a leaf from a crop, a swab from a surface, or a milk sample. This sample is then introduced to the testing device, whether it's a portable PCR machine or a simple biosensor strip. The device's AI or sensor analyzes the sample, and within minutes, the results appear on a screen or as a visual indicator. This straightforward workflow empowers anyone on the farm to become a food safety sentinel. Beyond pathogens, on-farm testing is crucial for managing chemical and environmental hazards. For instance, farmers can test leaf surfaces and fruit skins for pesticide residues to ensure they comply with domestic and international export standards, guaranteeing their produce is safe for all markets. Another major concern is fertilizer runoff. On-farm sensors can detect excessive nitrogen and phosphorus levels, which not only harm the environment and local water systems, but can also create toxic conditions for crops. Similarly, farms test for heavy metals, which can leach into the water from old irrigation pipes or enter the groundwater from nearby industrial areas. Water contamination is one of the single biggest causes of produce-related outbreaks. Farms must be vigilant, constantly testing their irrigation water to ensure it's free from both pathogens and chemical pollutants. And for farms growing grains, mycotoxin testing is essential. These toxins, produced by mold, can contaminate stored grain and livestock feed, posing a serious health risk to both animals and the humans who consume their products. This technology isn't a one-size-fits-all solution. It's being adapted for every corner of agriculture. On vegetable and fruit farms, farmers are testing soil for pathogens, irrigation, water for E. coli, and the surface of harvested produce for residues. In the dairy industry, biosensors are used to monitor milk for bacteria, check for early signs of udder infections in cows, and ensure that all milking equipment and water sources are sterile. Poultry farms are using rapid tests to screen for Salmonella and Campylobacter in litter, feed, and even live birds to manage flock health proactively. On large beef and livestock ranches, screening for pathogens in manure, water troughs, and feed is becoming standard practice to prevent the spread of disease. Even in aquaculture, farmers are using sensors to constantly monitor water quality, bacterial levels, and chemical residues to raise healthier fish. The application spans all farming philosophies. 2. Organic farms use testing to prove compliance with strict standards, while conventional farms use it to enhance efficiency and ensure safety. These technologies are already making a difference globally. In the U.S., following major E. coli outbreaks, spinach and lettuce farms in California now routinely use on-site tests to monitor their irrigation, water, and soil, preventing a repeat of past crises. In Canada, dairy farms are at the forefront of using biosensors. These devices are integrated into milking systems to provide real-time checks on milk purity and monitor odor health, leading to higher quality dairy products. Meanwhile, in the vast landscapes of Australia, livestock ranches use portable water testing kits to screen for heavy metals and bacterial contamination in remote water sources, ensuring the health of their herds across thousands of acres. And in the UK, high-tech greenhouses are deploying AI-powered sensors that track humidity and airborne fungal spore levels. The system can predict a potential mold outbreak and automatically adjust the climate to stop it, protecting valuable crops like tomatoes and cucumbers. The benefits of this shift are transformative. First and foremost, fewer outbreaks and recalls. By catching contamination at the source, we prevent public health crises and save the industry millions of dollars in recall costs and lost revenue. This, in turn, builds higher consumer trust. When people know that brands are investing in cutting-edge safety from the ground up, their confidence in the food supply grows. On a global scale, it means better export quality and easier compliance. Many international markets have strict safety documentation requirements, and on-farm testing provides the verifiable data needed to access them. The benefits extend to the farm itself, leading to healthier crops and livestock. A preventative approach to disease and contamination results in stronger plants and more robust animals. Finally, it drives more sustainable farming. By using AI and sensor data, farmers can reduce the overuse of chemicals, optimize their water usage, and create cleaner, more efficient farming systems that are better for both the planet and their bottom line. Of course, the transition isn't without its challenges. The initial cost of advanced devices can be a significant barrier for small-scale farmers. Additionally, this equipment requires proper calibration and maintenance, and farmers and their staff need training to use it effectively and interpret the results correctly. Environmental factors can also pose a problem. The accuracy of some sensors can be affected by extreme weather conditions like high humidity, dust, or intense heat. And as farms collect vast amounts of data, issues of data management and privacy arise. Who owns the data? And how is it protected? These are important questions we need to address as the technology becomes more widespread. Acknowledging these limitations is key to developing better, more accessible solutions for the future. Looking ahead, the future of on-farm safety is incredibly exciting. We're moving towards fully automated, AI-powered labs, stationed directly on farms, performing continuous robotic testing around the clock. Imagine drone-based scanning, where drones equipped with hyperspectral sensors fly over fields, detecting contamination or stress in crops from the air. We'll see smart soil systems, where the soil itself is embedded with a network of microsensors that predict nutrient deficiencies or contamination threats in real time. This data will feed into predictive outbreak modeling, where AI algorithms forecast contamination risks before they even materialize, allowing for preemptive action. Ultimately, this could lead to a global farm-to-table safety network, where data is shared securely across the world, enabling a rapid, coordinated response to any potential food safety risk, no matter where it originates. From the soil to your plate, the role of the farmer as a guardian of our food supply has never been more critical. On-farm testing technologies are not just tools. They represent a fundamental shift in our approach to food safety, empowering farmers to be the first and most effective line of defense. They are building a future where our food is not only more abundant but fundamentally safer. What are your thoughts on these new technologies? Do you think they will become standard on all farms? Let us know in the comments below. We love hearing from you and encourage a lively discussion. If you found this video insightful, please give it a thumbs up, and don't forget to subscribe to Fields of Innovation and hit the notification bell. Share this video with anyone who cares about where their food comes from. Thanks for watching, and we'll see you in the next one.